So what is data? Data is like the answer to a question. That's it. That's it. That's literally it. Like the point is, you do a survey and you collect data. There are two types of questions. When you ask somebody, like, which is your favorite parent? That's like mom or dad. That's not quantifiable. So this is a qualitative data. This is non-measurable in terms of numbers, like words and shit. And we have quantitative, which is quantifiable, which is like 1, 2, 3, like how many penises you suck today. Well, it's like 1, 2, 3, I don't know. And it's it's a continuous, meaning it can be like broken down in like meters. Okay, that is a penis. Like a ruler, 1 meter. And it can be broken down at 0.1, and so on and so forth. Like you would think that age 1 to 2, like this is a discrete gap, but it's not. Like this, there's like 12 months in a year, so on and so forth. So anything that's measurable is continuous. Something that is discrete, it has a clear gap, like 1 apple, 2 apple, or 1/2 apple. But there is a gap, like mostly it's just 1. I don't fucking know. Maybe like rating from 1 to 5. I don't know, something like that. And in statistics, there are outliers. Outliers are like numbers that do not fit within the expected range, if that makes sense. Like if your data sets of like ratings look like how tall are you? So everyone's like 162, 165, 170, 179. Is it sorted for convenience sake? Something like that. 180, 181. And then there's this guy who's like 240. Like in this region, like this is our universe of data sets. Like maybe we sample a region. Let me take a sample out of it. And this is maybe someone is this tall, but like chances are it's like he's lying or is an outlier. So we call it an outlier, and we remove it before we process it into the data. This is very important. So we have tables, like the thing. Whoop. Okay, don't be confused with these two. Like this is the variable, and this is the frequency offset variable. Frequency. So the frequency is just how many times this variable is repeated. So like maybe you have a data point of 1 20 times, maybe 2 14 times, 3 20 times. So what this is your n. So what is it? 20, 40, 54. And then we have cumulative frequency, CF. Like this cumulative addition basically means addition. Alright, addition. The fuck is addition? You add it. So this frequency is 20, and when you add this, it becomes 34, and then 54. And we have something called the inverse cumulative frequency, where you start from 54 minus 20. What was that? 34 minus 14. That's 20. 0. Something like that. something not like that, I guess. Maybe it is like that. Maybe I am tripping. But it's something along these lines. 54 minus 20 looks about right. Does it? No, it doesn't. The fuck? Yeah, I don't know. I don't care. And the percentage of the cumulative frequency. We just take this 34, or no, 20, divided by 54, and then we times it by 100. We get a percentage, so on and so forth. All these should add up to 100%. So should these. These should add up to the 54. Yeah. And this is just using the percentage of the inverse. And this is for continuous. No, yet discrete. Because we don't have classes for discrete, if I remember. Nope. Nope. It is continuous. Fuck me, bro. Continuous. Cool. So this is just the data point itself. Like what is measured is being like just put right into the table. We don't have to calculate the class basically. And we move on to discrete. So in discrete there's something called classes. What the fuck is a class? It's just the length from one data point to another. Nope, not data point. The size, cause like there's so much of it. You know what I'm saying? So like, so when it is discrete, you put the data points in because there is no gap between data points. Fuck. Okay. And when it is continuous, I should probably edit this continuous, and this to be discrete. Because there are gap like we can't reliably get the gaps from the data points. So let me write some fake data. Nah, I'm too fucking lazy for this shit. I am going to copy it straight from the book. Yippee. Yippee. So, okay, how many n? What is our sample size? 40? Two, 1, 4. Yeah, I don't know. This is the formula, 2k equals n. So we try to get as close as possible without we try to get the bigger amount of this to be bigger than n if possible, because we cannot fit the n into a smaller. So 5 times is 32. 6 times is 64. Let me check that. Yep. So we have our n at 6 classes. So from 37 to 60, there will be 6 classes. And we will have I, size of class, 60 minus divided by 6. Calc that real quick. Oh my god, calculator time. Oh, what the hell? cannot have that number. So our classes look something like, we take this to what, 37 plus 4 is 41. 41 excluding, and this is one of our classes, and we treat this like our data point, but we also take our xe to be the middle of this. So what, 37, 4 divided by 2 is 2, so 39, this is 39, and then so on, right? What is this, 41, 41 plus 4 is 45, 45 all the way to 60, 49, something like that. And we all take the x2, x3 for our calculations, and we do the fucking table again. Just do the table, man. Do the table, you understand it. These are our classes. I'm so fucking lazy, bro. 37, 41. XE is 39. Appears twice. Accumulator. Just do it. This number should, the addition of all these FEs should be 40. And yeah. So after this, this is just fucking, just do it yourself, bro. We have modes here. Modes. Let's say we have this data set of something. I don't know what it is. Something. So the question is, what appears the most? Out of these 3 data sets, data points, these are called data points, which one appears the most? So we look at the frequency. This appears 20 times, so the MO is 30. That's it, bro. And if we have something like and since this is both equally as high, we will have 2 modes, 1 and 3. Like, this is not the mode, it just the amount this point appears, like it appears 20 times, and then this appears 14 times, and this appears 20 times again. That's a mode. That's the mode. Anyways, and modes can be used for qualitative too, like your mom and I don't know, penis. Like this is just the data of any question. Like your mom could appear 2 times while penis appears 1 time. So your mom is the mode. Get it? Right. For continuous, just the addition of the classes divided by 2. So it's the picture, this thing of the classes that appears the most. Look, you can see on the left, like this class appears 20 times. So the picture ID is our mode. 49 minus 45. This is plus 47. Okay, mean. It's denoted by X bar. We call it average. And once this is just average, bro. You add it and you divide. So like, look down here. So 1 shows up 20 times, 2 shows up 4. Like it's like 1 times 20 plus 2 times 14 plus 3 times 20 divided by 54. That is your x bar. You run the calculation. I don't want to run the calculation. We have median, middle value when sorted. So we have, like, think of it as an array of elements. Like, this has its own position in this array. I don't know, yeah, something like that. It's the easiest way to think about it. This shows up like what, 20 times. This shows up 14 times. It shows up another 20 times. So what is the middle? Like, what is in the middle of this array? What is it? So we have 54 elements divided by 2 is 27. So which number is at the 27th element? You just add this number. It's just like 34. So 27 is smaller than 34. And 27 is bigger than 20. So it clearly is 2. Median is 2. That's it. Oh, something funny is skewedness. So we can graph our data. It looks like this. Like, these are our smaller data points, middle data points, bigger data points. This happens if everything is equal. Median is equal to mode is equal to average. So it looks like a normal distribution. But most likely the case it is not. So, yoink. I think this is pretty important in stats. Right skewed. It's funny that it's called right skewed, but the data is left. Get it? Mode. This happens when your smaller data points, there are more smaller data points than there are larger ones. So our mode is one of the small data points. The median is also small, and the mean is small. Everything is small. And it's called a right skewed graph or chart or whatever. Which is funny because it's bound on the left. And it's the opposite for a left skewed. Okay, measure of dispersion. So we have range, classic, from 20 to 30, 30 to 40, 40 to 50. What is the range? Like, what is the diagonal of this data set? So the minimum is 20 and the maximum is 50, or aka 49. Fucking bozo. So our our range is 20 to 49 inclusive. This is a set. So deviation, mean deviation is like how much does the data vary from the mean, and it's calculated with this formula, sigma boy. Like this thing will be found using your table. Like, once you do the table, this table, you will be able to find your mean deviation and variance and so on. It's not that hard. Like, you should probably do it with the table, if I'm gonna be honest. Like, add another row here. It says xi minus x bar. It's related. It's somewhere there. I forgot where it is. And then the next row for variance would be that squared. Yep. And this is f equals 1. This is when the frequency of everything is 1. So when it's not, it's multiplied. Like this thing would be multiplied by the amount of time it shows up, and that would be your deviation type shit. And variance is just a play, like this is like copy this, but give it a square. Variance, boom, fucking variance, wow. And do this, or this goes like this instead. And our standard variation, deviation, is just the square root of our variance. This is var s, or s squared. That's it. That's it for the first chapter. Not much more you need to know. Just do the lomhat and you will understand a lot.